When graphing functions, there's two special types, even and odd. So, even values can be flipped across the x-axis and be the same. And so one example of an even function could be a simple parabola, because they are symmetrical, right? If they have a vertical symmetry, a vertical line of symmetry, they can be flipped across the the y-axis and still be identical. Okay. Now for the odd. So what does odd mean? Well, odd means it can be flipped across the x and y axis. And one example that you may not have expected is a simple line, simple linear line. Because I'll show you. Let's start with our line right here, okay? And now let's flip it across the y-axis, okay? So that it's going to look something like this, okay? And now let's flip it across the x-axis. So now the negative values are going to be positive and the positive values are going to be negative. And we're back to where we started. So how can we find if it's even or odd if we don't have a graph? Well, we can use their table, okay? So if we were to have their function table, so if we were to have something like, let's have a parabola, we could do -2, -1, 0, 1, 2, and our results are going to be 4, 1, 0, 1, 4. And we know that this is even because it's symmetrical about a y value. And in this case, it's symmetrical about 0, right? So, and this is because, you know, on each side, like if you go 1 out, you get a 1. If you go 2 out, you get a 4. And this will continue. So 3, -3, -3. If I can squeeze that, -3, that's 9, and 3, it's 9. So it's symmetrical infinitely. Now, how can we find if it is odd? Well, if it's odd, let's use the example of a line, a straight line. We can do -2, -1, 0, 1, 2. How about that? And let's do a simple y equals x line. So in this case, we have -2, 1, 0, 1, 2. And how I know this is odd is because 1/2 is negative, 1/2 is positive. And in other words, if you were to take the absolute value of 1/2 of the graph, you would get, it would be equal or symmetrical to the other half. And if you were to have just the equations, you can test this by making them negative, or, you know, the equivalent of flipping them across the y-axis and then across the x-axis. Okay, so now let's do some examples, okay? Well, if we have y is equal to 3x plus 4. Well, immediately some of you might think, oh, well, that's a line, so then that means that it has to be odd. Well, first it's good to check it, because in some cases it could be neither, okay? So let's look at this. Well, let's flip it across the y-axis, or make x negative, or substitute x for negative x. So then we have y is equal to, or we can make it, actually, we can say f of x, how about that? F of x. And that's equal to -3x plus 4. And now let's make it negative, with the whole expression negative, which is the equivalent of flipping it across the x-axis. That's -3x plus 4. And so that gives us positive 3x minus 4. So this tells us that this is neither even nor odd, because when we flipped it across the y-axis it was not identical, and then when we flipped it across the x-axis it was still not identical. Now let's do one more. How about we have y is equal to, or f of x is equal to x squared plus 4. Okay, well, seeing that it's a quadratic, we can assume that it's probably either even or neither, right? So let's make it negative, okay? Or sorry, let's flip it across the y-axis. So, and what that means is just substituting x for negative x. So negative x squared plus 4. And notice when you square a negative number, it becomes positive, so there's actually no difference. So what we found is that f of x is equal to f of x flipped across the y-axis. So in other words, this function is even. Let's do another one. How about we have y is equal to x cubed plus 2x plus 4. Let's test if this is even or odd, or neither. So we have f of x is equal to, so let's first flip it across the y-axis, right? So we have negative x cubed plus, that was bad, 3, 2 times negative x plus 4, okay? So now we're left with the negative x cubed plus negative 2x plus 4. And now let's flip it across the x-axis, which is just making the whole expression negative. So then we have negative x cubed plus negative 2x plus 4. We make that negative, and we get x cubed plus 2x minus 4. So everything's the same except that it's a plus 4 here and a minus 4 here. So this is neither even nor odd. And finally, let's do our last one. How about we do f of x is equal to 4x, okay? So what can we do here? Well, we can flip it across the y-axis, which makes it negative x, so it's negative 4x. And then we can flip it again across the x-axis, so then we get f of x is equal to the negative of negative 4x, okay? And the negative of a negative is a positive, so we're left with f of x equal to 4x, or I guess of negatives. So what we found is that f of x is equal to negative f of negative x, and in other words, f of x equal to 4 of x is an odd function. So now let's talk about scaling, or compressing or stretching a function. So if we were to have a function f of x, and we were to make it, how about f of 2x, we are compressing it horizontally. So let's just do one example. What if f of x was x squared? Okay. So we would have something like this, like that. And if we were to multiply x by 2, it would become a sharper incline, kind of steeper. Or a way to think about it is kind of compressing it horizontally. Okay, now let's talk about another one. How about we do f of x, and we turn that into 2 times f of x. Doing this will create a function that looks something like it's kind of in between the other two. Okay, so something like that, okay? And again, multiplying it by 2 kind of compresses it more. Or you can think about it stretching it vertically. And another difference when you're multiplying the actual function instead of x itself is that the x-intercept changes. So if we were to have y is equal to x squared plus 2, how about that? Well, let's write down that function, okay? So if we get our graph out, and we were to create this function here, it would look something like that, okay? We can all agree. But if we were to multiply it by 2, so the x by 2 plus 2, then it would become more compressed vertically, okay? More compressed. Sorry. Plus 2. It would become more compressed horizontally, okay? Something like that, okay? But if we were to multiply the whole thing by 2, sorry, wrong parentheses. If we multiply the whole thing by 2, we would get x squared plus 2. We would get, again, that kind of in-between compression, in-between stretching. Wait. So we would kind of get that in-between, so 2 times x squared. But but our y-intercept is going to be multiplied by 2, so it's going to double. So we're going to get something like that. So multiplying x by 2 and multiplying the function by 2 can make a large difference. I know I normally say go check out Khan Academy for more examples, but I 100% suggest looking at Khan Academy to fully understand this chapter. It's one thing to learn about the concept. I think it's another thing to practice it and see more examples about it. But right now, I'm going to talk about kind of how different graphs look like. So, at Khan Academy, they talk about the different graphs and how they can be transformed. Right now, I'm going to briefly tell you what they look like, okay? So, you've seen my square root function example earlier. So, for our square root function, it's going to look like, so y is equal to the square root of x. It looks something like this, okay? Cube root is very similar, but it can be in the negatives. So, it might look something like that. Okay. Now, next, for an exponential function, which I assume most of you are aware of, and it can look something like this, like that. Okay. And probably a new one for most of you, a logarithmic function. Logarithmic function is, like I've said in one of my previous videos, logarithmic functions are the inverse of exponential functions. So they will look something like this. Okay guys, thanks for watching. So today we talked a little about the transformations of functions. It's kind of difficult when I just have to draw them all. I think you should check out Khan Academy, and I think a cool website to check out Desmos Graphing Calculator, and that can help you kind of help visualize these different graphs. But thanks for watching. Peace.